Hi guys, Dr. Kruse here. Algebra lesson about average rate of change. We'll get to that in a second. I want to start by showing you a trick because sometimes we'll put in kind of lengthy expressions and maybe we'll get it just a little bit wrong, like maybe that 5 should have been an 8 or something like that. And I want to show you how to bring up the last thing you entered on your calculator. All right, so maybe I'm on the 83 and I've entered this expression here and I messed up, and maybe I meant to make that 1 a 7 or something like that. Well, I need to pull up my last entry. Now it's right here in yellow, entry. All right, it's the second function of this enter button. First function is enter, second function is entry, third function is solve. We want entry. We want the second function of this button. So I'm going to do second entry. And what it does is it pulls up the last thing you entered, pulls up your last entry. And now all I got to do is just arrow over to whatever I want to change that one number and hit enter, okay? So if you have a long expression and you don't want to type the whole thing in over again, go to second entry and that'll pull up your last entry, and then arrow over and fix what you need to fix. On the 84 plus, it's actually easier. I'm just going to arrow up right here, arrow up, and hit enter. And that brings back the last thing you entered. And then just arrow over, change whatever you need to change. All right, I do want to review averaging. I'm going to ask you to average here in a minute. If I'm averaging two numbers, I just add them up and divide by how many there are, okay? So if I ask you to average 2, you just add them up and divide by 2. Add them up, divide by 2. On the 83, remember you have to enclose the top in parentheses, and usually we enclose the bottom in parentheses, but if there's just one number, you don't have to use the parentheses if you don't want to. On the 84, you just use your F1 key. It's on the top left in green. Pull that up, bring up the picture of the fraction, and just enter your values. Let's also review rounding real quick. If I ask you to square root 43 and we get this monster right here, rounded to 2 decimal places, remember, rounded to 2 decimal places, we're going to keep 2 numbers after the decimal. So I'm going to keep the 5 and the 5 after the decimal, 2 numbers after the decimal. Before you write that down, take a peek at that next number. It's a 7. That means I got to round this one up to a 6. So that answer is going to be 6.56 rounded to 2 decimal places. Sometimes it comes out even. All right, square root of 36 is 6. If they specifically tell you to round to 2 decimal places, even though it came out even, technically it's 6 point, and a million zeros. So technically it would be 6.00. Lots of times your homework will let you slide on that, but technically that would be 6 rounded to 2 decimal places. All right, and next I want to review slope, because today we're going to call it average rate of change, but I want you to think of it as slope. So if I have the 0.25, that's a dot that I went 2 steps right and 5 steps up and put a dot there. And 49, I went 4 steps right and 9 steps up. This is my x, this is my y, this is my x, this is my y. If I want to find the slope, or how steep this line is that connects these 2 points, well, there is a formula. It's y1 minus y2 over x1 minus x2. That's the formula for slope. We designate slope with a lowercase m. All right, I think it's a French word that means slope. So basically, I want to subtract my y's on top and my x's on bottom. And it's really easy to remember. You don't have to memorize the formula. If you just remember rise over run rhymes with y's over x's, okay? Rise and y's rhyme. So think rise over run rhymes with y's over x's. These are the y's, these are the x's. So I'm going to subtract the y's on top and subtract the x's on bottom. Later on, we'll call this the difference in y over the difference in x, all right? When we start to speak calculus and stuff. But for now, I'm just going to say subtract the y's on top and subtract the x's on bottom. Rise over run rhymes with y's over x's. Here's my y, 9. Here's a y, 5. 9 minus 5, that's 4. Good. Here's an x, 4. Here's an x, 2. 4 minus 2 is 2. All right? So I did 9 minus 5 over 4 minus 2. The only real rule here is if I start with 9 on top, I have to start with 4 on bottom. We got to go in the same order. You can start wherever you want, but go in the same order whenever you decide which point you're going to start with. So this simplifies to 4 over 2 or 2 over 1. Now if it's over 1, we don't write over 1 because we're lazy. But they mean the same thing. This line that goes from this point to this point is going to go 4 steps up for every 2 steps it goes over. Or saying that simpler, it goes 2 steps up for every 1 step it goes over. It's a pretty steep line. I worked it backwards here to show you that you can start with the 5 if you want to. I can go 5 minus 9 over 2 minus 4. It's just if you start with the 5, you got to start with the 2 on bottom. All right? You come up with negative over negative, which simplifies to positive 2, and so you wind up at the same place. So today, when I say average rate of change, I just want you to think slope, all right? I want you to think slope in your head, but we're going to keep using the words rate, speed, velocity. Technically, speed and velocity aren't quite the same thing, but it's close enough for this lesson. So you're just asking how fast are things changing, on the curve or whatever at this moment. I'm just asking, how is the slope changing? How is the vertical distance changing with reference to the horizontal distance? Okay, here's a table we're going to work off of just to kind of explain this average rate of change idea. So I'm given a table of 1970, 1980, 1990, 2000, and 2010. So we're starting in 1970, and we're going up 10 years at a time, all right? And they're going to call that the year. Now, we can't designate that with a Y because we stay away from X's and Y's. We use X and Y for ordered pairs, so we stay away from Y's. They're going to call it D for date instead, but it means year, D for date. And then population started at 100. It could be 100,000, 100 million, whatever they're measuring in. In 1970, population started at 100, and then it rose to 120, and it grew to 140, then 160, then 180. So it starts at 100, and it grows at 20, let's say people. It could be fish or bears or foxes or whatever. It grows at 20 people every 10 years. So every time 10 years goes by, it goes up 20 people. This is a growth function, all right? We started with 100 and ended up with 180. That definitely grew. This is a growth function. So just think of it as a good old-fashioned X and Y table, but we're not going to use X. We're going to use D instead, and we're not going to use Y. We're going to use N for number. I don't know why they didn't use P for population, but they chose to use N for number. So the number of people, depending on what year we're talking about. All right, now it's easy to see what the population was in these, every decade, the 70, the 80, the 90. It's easy to see how many people they had in those years, but what about the years in between, like 1972, 1979, 1981? What about the years in between? So for example, what's the population of 1993? Well, 1993 is in between these two, all right? I need to figure out, it's going to be some population in between 140 and 160. It's pretty easy to figure out, actually, all right? All you got to do first is find what we're going to call the average rate of change, sometimes abbreviated to ARC. I got to find out how fast it's growing, or its rate of growth. Later on, I'm going to call it growth rate, all right? It's just the slope. So if I just think about this, it's growing 20 people every 10 years. Well, that's 2 people per year. You can kind of do that in your head. But here's the math, all right? We just go back to our formula, slope, which we're calling average rate of change now. Subtract the y's on top, x's on bottom. You can start wherever you want. I started at 160, so I started here. I said 160 minus 140 over 2,000 minus 190. Y minus y over x minus x. Rise over run. All right, here's the numbers down here. It works out to 2 people per year. So if you can't just see it in your head, you can figure it out real easy by doing slope. And you can calculate slope anywhere in the table. Y minus y over x minus x. You'll wind up at, this thing is growing 20 people every 10 years, which means 2 people every 1 year. So it's growing at a rate of 2 people per year. Okay, now that we know that, I can find out how many people I have in 1993. Well, 1993, that's just 3 years after this. So back up to whatever year you have in the table. I'm going to back up to 1990 because I have that in the table. That's going to be my starting point. I know in 1990 I had 140 people, and I need to find out how many I have 3 years later. So I need to add 3 years of growth. It's growing, all right? So I need to add 3 years of growth. So in 1990, I had 140 plus another 3 years of growth, and it's growing at 2 people each year. So I need 3 of those 2s. It's growing 2 people per year. So the population in 1993 is whatever it was in 1990 plus 3 years growth. I got to figure out the growth rate, which we did right here. The growth rate, the average rate of change, the growth rate is 2 people per year. So here's the fancy math way of writing it. The number of people in 1993 is the number of people we had in 1990 plus 3 more years of growth, 3 more years of average rate of change, 3 more years of slope, all right? Start thinking about this as like a growth rate. So the number of people in 1993 is 140. That's how many we had in 1990, plus 3 more years of growth at 2 people each year. So 3 times 2, that's going to be 6. I need to add 6 more people. 3 more years of growth at 2 people per year. So we end up with the number of people in 1993 is 146. All right. You guys can pause and try and figure these out the same way if you want to. If you want to pause the video and practice. But next I'm going to do 1987. How many did we have in 1987? Back to my table here. I don't know. 1987, it's in between 1980 and 1990. So I'm going to go backwards in time. I'm going to go to 1980, back in time to 1980, when I knew I had 120 people. And I'm going to add, it's 1987, so I need to add 7 years of growth. 7 years of growth. All right, so the population in 1987 is, now we already did the slope, the growth rate. The growth rate is 2 people per year. So the population in 1987, or the number of people with respect to 1987, is how many we had in 1980 plus 7 years growth. So writing it a little bit fancier, the number of people we had in 1987 is the number of people with respect to 1980 plus 7 years of growth rate. Remember, that's average rate of change. Just think of it as rate. Just think of it as growth rate, because this thing is growing. It's getting larger. So the number of people with respect to 1987 is the 120 that we had in 1980 from the table, plus 7 years of growth, and we're growing at 2 people each year. 7 times 2, that's 14. I need to add 14 to the 120 that we had in 1980 for a total of 134. Now I'm going to show you this over here. The last thing I'm going to show you is just a shortcut. And I don't care if you use the shortcut or not. But if I ask you for 2005, well, heck, 2005, that's exactly midway between these two. It's exactly halfway. So all I got to do is find the number that is exactly halfway between 160 and 180. It's easy for us to see that that's going to be 170, but here's the math. To find a number that's exactly halfway, all I got to do is average the y values. So the number of people in 2000 was 160. The number of people in 2010 was 180. Add those up, that's 340 divided by 2, that's 170. We can just do it by averaging. That's why I showed you averaging at the beginning of the lesson. It is a shortcut you can use if your date is exactly halfway between. You don't have to. You can always do it this way. I can go back to the year 2000, take those 160 people that I had in 2000, and add 5 years of growth at 2 people each year. So I would add 10 to the 160 and get 170. You can always do it this way. But if you happen to notice that it's halfway in between, sometimes it's quicker if you just take an average of the y values. All right, guys, that's it.